For the full bin algorithm, we look to find combinations of numbers that will add up to the bin size. Now, it's personal choice which ones you choose, but try and be sensible about how you're choosing the numbers. What I will often do is choose the largest number and work out how to pair it with another number to fill it up, or to fill a bin up entirely. So if I have the 52 and the 8, I know that I've got a full bin in that particular place. When I'm looking for other numbers, I'm just going to look at different ways of finding numbers that pair up. So I might choose the 45, the 7, and the other 8, because I know that that's going to make another one. 45 plus 7 plus 8 is going to give me 60 in there. Another combination I could choose, maybe we could have the 30, the 12, and the 18. That will give me another selection there, 30, 18, and the 12, and that's got another full bin. Now when I take everything else, if I do 16 and 14 is 30, that makes 40, 49, 58. I've used all of them now, and do make sure that you check that you've got all of them. Yep, that's all of them. It hasn't filled the bin up, but I've only had to use one more bin, so I know it's a pretty good solution. And actually I've got 3 full bins and one that is virtually full. Now the problem with this algorithm is that it depends on the choices that you make. You may make different choices from somebody else, and you'll get a different number of bins that you need to use depending on which values you've put together. So it's not a particularly efficient one, but in certain situations it can give a very good solution. In the case that I've just shown, that is quite an optimal solution. But it's quite simple and straightforward to use.